Good day everyone. I am Ma'am Chrisline, and in this video lesson, I will be discussing about geometric series. Are you ready? Let's begin. At the end of the lesson, it is expected that students will be able to demonstrate knowledge and skills related to sequences and apply these in solving problems. Specifically, students should be able to first, determine the sum of the first n terms of a geometric sequence. Second, derive the formula for the sum of a finite geometric series when the common ratio is not 1, and use the formula to solve problems. Lastly, find specific terms of geometric series. Now, before we begin with the discussion, let us first recall what is a geometric sequence. A geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a fixed number called common ratio. In the past video lessons that you have watched, you have learned what is a geometric sequence. Now, what is the difference between a geometric sequence and a geometric series? We have a geometric sequence 1, 2, 4, and 16. So its equivalent in geometric series is 1 plus 2 plus 4 plus 8 plus 16. What is the difference? That's right. In geometric series, you will get the sum of the geometric sequence. Another example, 4, negative 12, and 36. That is 4 plus negative 12 plus 36. Lastly, 5, 1, 1 over 5, and 1 over 25. That is 5 plus 1 plus 1/5 plus 1 over 25. Now, before we go to the main discussion, let us first observe the shapes. We have here a rectangular sheet of paper. Let's assume that its area is 1 square unit. Let us cut it in half and lay down 1/2 of the pieces. What part of the whole do we get? 1/2. Next, let us cut again the remaining half and lay down 1 of the quarter pieces. What do we get? 1/2 plus 1/4. So that is 3/4 of the whole. Next, continuing the process, let us cut again the remaining piece into half and lay it down. What do we get? 1/2 plus 1/4 plus 1/8. That is 7/8 of the whole. Lastly, let us do the same process and lay it down as if rebuilding the original piece of paper. What do we get? 1/2 plus 1/4 plus 1/8 plus 1/16. That is a total of 15 over 16. What can we observe from this experiment? If the process of cutting down the remaining piece of paper and laying down one of the pieces is continued, we can obtain a geometric series. The geometric series is 1/2 plus 1/4 plus 1/8 plus 1/16 and so on until 1/2 to the nth power. To further understand this topic, let us derive the formula for the sum of geometric series. First, let us have an example. Consider the geometric sequence 3, 6, 12, 24, 48, and 96. Let S sub 5 be the sum of the first 5 terms of the sequence above. So, S sub 5 is equal to 3 plus 6 plus 12 plus 24 plus 48. First, we multiply both sides by 2. We would get 2s sub 5 is equal to 3 times 2, that is 6, 6 times 2, that is 12, and so on until 48 times 2, that is 96. Now, let us subtract 2s sub 5 from s sub 5. We would get s sub 5 minus 2s sub 5, that is negative s sub 5. 3 minus 0, that is 3. 6 minus 6 is 0. 12 minus 12 is 0. 24 minus 24 is 0. 48 minus 48 is 0. And 0 minus 96 is negative 96. Now, simplifying, we would get s sub 5 is equal to 93. From that example, let us derive the formula for geometric series. Consider the sum of the first n terms of a geometric series s sub n. So, our s sub n would be a sub 1 plus a sub 1r plus a sub 1r squared until a sub 1r raised to n minus 1. Multiplying both sides by r, the same process as what we did earlier, we would get r s sub n is equal to a sub 1r plus a sub 1r squared until a sub 1r raised to n. Subtracting r s sub n from s sub n, we would get s sub n minus r s sub n is equal to a sub 1 minus 0 is a sub 1. A sub 1r minus a sub 1r, that would be 0. Cancel all the same terms. And for the last one, 0 minus a sub 1r raised to n, that is negative a sub 1r raised to n. So we have s sub n minus r s sub n is equal to a sub 1 minus a sub 1r raised to n. Now, factoring both sides of the resulting equation, we would get, factor out a s sub n here, that would be s sub n times 1 minus r. Then, for the right side, factor out a sub 1. So we would get a sub 1 times 1 minus r raised to n. Dividing both sides by 1 minus r, where 1 minus r should not be equal to 0, we would get s sub n is equal to a sub 1 times the quantity 1 minus r raised to n all over 1 minus r, where r should not be equal to 1. So that is our formula for the sum of geometric sequence. Now, let us recall the formula for geometric sequence. We have a sub n is equal to a sub 1 times r raised to n minus 1. Multiplying both sides by r, we would get a sub nr is equal to a sub 1 r raised to n. To get the second formula for geometric series, we should substitute a sub nr to a sub 1 r raised to n. So from the first formula, let us replace a sub 1 r raised to n by a sub nr. So now, we have another formula. S sub n is equal to a sub 1 minus a sub n raised to r all over 1 minus r. The same, r should not be equal to 1. What if we have a geometric series where r is equal to 1? That means the terms in the geometric series are constant. For example, 4, 4, 4, 4, 4. The sum of the geometric sequence is 5 times 4 is equal to 20. Therefore, if r is equal to 1, we can get the sum by multiplying the number of terms to the first term. So our formula would be S sub n is equal to n times a sub 1, where n is the number of terms and a sub 1 is the first term. Whereas, if r is equal to negative 1, for example, 2, negative 2, 2, negative 2, what is the sum? 0. How did we get 0? 2 plus negative 2 is 0, plus 2 plus negative 2, that would be 0. Another example, 5, negative 5, 5, negative 5, 5. What is the sum? 5. So what is the difference between these two? The first one has even number of terms, while the second one has odd number of terms. Thus, if r is equal to negative 1, the sum would be 0 if n is even. Why? Kasi magiging partner-partner lang siya. So, 2 minus 2 is 0. The other one, 2 minus 2 is 0. So, kapag even siya, partner-partner, lahat makakancel lang. So, ang magiging sum niya ay 0. Kapag naman odd ang ating number of terms, ang matitira dyan is yung first term, while the rest would be cancelled out. So, our sum would be a sub 1. So, we have our third and fourth formula. The third formula is used when r is equal to 1, and the fourth formula is used when r is equal to negative 1. Remember, the sum S sub n of the first n terms of a geometric series is given by S sub n is equal to a sub 1 times the quantity 1 minus r raised to n all over 1 minus r, or S sub n is equal to a sub 1 minus a sub n times r all over 1 minus r, where r should not be equal to 1, where S sub n is the sum of terms, a sub 1 is the first term, r is the common ratio, n is the number of terms, and a sub n is the last term. Now, let us have examples in finding the sum of the first n terms of a geometric sequence. What is the sum of the first 10 terms of 2 plus 2 plus 2 plus 2, and so on and so forth? Let's identify the given first. Our a sub 1 is 2. R is 1. And n is 10. Why 10? We need the first 10 terms. So, which formula should we use? S sub n is equal to n times a sub 1. So, just substitute. S sub 10 is equal to 10 times 2. 10 times 2 is 20. So, S sub 10 is equal to 20. Therefore, the sum of the first 10 terms is 20. What is the sum of the first 11 terms of 3, negative 3, 3, negative 3, and so on? Let us find the given. Our a sub 1 is 3. Our r is negative 1. And our n is 11, since we need to get the sum of the first 11 terms. Now, which formula should we use? Since r is equal to negative 1 and our n is odd, therefore, our S sub n would be equal to the a sub 1. And our a sub 1 is 3. So, S sub 11 is equal to 3. Thus, the sum of the first 11 terms is 3. For the third example, Find the sum of the first 10 terms of the geometric sequence 3, negative 6, 12, and negative 24. Let's identify the given first. Our a sub 1 is 3. Our r is negative 6 divided by 3. That would be negative 2. And our n is 10 since we need to find the first sum of the first 10 terms. We will use the formula S sub n is equal to a sub 1 times the quantity 1 minus r raised to n divided by 1 minus r. So, substitute the given to the formula. Our S sub 10 would be 3 times 1 minus negative 2 raised to 10 over 1 minus negative 2. Simplifying the expression, we will get 3 times 1 minus 1024 over 1 plus 2. 3 times negative 1023 all over 3. So just cancel 3. We will get S sub 10 is equal to negative 1023. Therefore, the sum of the first 10 terms is negative 1023. For the next example, find the sum of the terms of a geometric sequence whose first term is 3 and whose last term is 46,875 and whose common ratio is 5. Now, let's identify the given from the problem, where a sub 1 or the first term, that is 3. Our r or the common ratio is 5. And our a sub n last term is 46,875. Which formula should we use? S sub n is equal to S sub n is equal to a sub 1 minus a sub n times r over 1 minus r. So let us substitute the given to the formula. That would be 3 minus 46,875 times 5 over 1 minus 5. So, simplifying the expression, we will get 3 minus 234,375 over negative 4. 3 minus 234,375, that is negative 234,372 divided by negative 4, we will get S sub n is equal to 58,593. Therefore, the sum of the terms of the geometric sequence is 58,593. Now, let's try to find the specific terms in a geometric series. What do we mean by this? Yung hindi S sub n ang hinahanap. Paano kung ang nawawala ay si n? Or ang nawawala ay si r? Let us have some examples of those problems. Determine how many terms the geometric series has and find the sum. So we have here two examples na kailangan nating hanapin kung ilang terms meron lahat ang geometric series na ito. And we also need to find the sum. For the first one, we have 6, 30, 150 until 468,750. Let's identify the given first. Our a sub 1 is 6. Our r is 30 divided by 6, that is 5. And our a sub n, or the last term, is 468,750. Now, which formula should we use in finding the n? The formula for geometric sequence. So, ang una natin gagawin, aalamin muna natin kung ano ang value ng n gamit ang formula ng geometric sequence. Now, let us substitute the given. Our a sub n is 46,870. Our a sub 1 is 6 and our r is 5. First step, divide both sides by 6. We will get 78,125 is equal to 5 times 5 raised to n minus 1. Now, kapag ganito na ang problem, kailangan gawin nating pareho ang base ng dalawang side. So, since meron tayo sa kabilang 5 raised to n minus 1, yung kabila dapat maging 5 raised to something din. So, 78,125 is equivalent to 5 raised to 7. So, we have 5 raised to 7 is equal to 5 raised to n minus 1. Now, let us equate the exponents. We have 7 is equal to n minus 1. Simplify, we will have 7 plus 1. So, the value of n is 8. Now that we have the value of n, we can find the sum of this geometric series. So, let's substitute the given. S sub 8 is equal to 6 times the quantity 1 minus 5 raised to 8 over 1 minus 5. So, using your calculator, you will get S sub 8 is equal to 585,936. For the next example, please pause the video and solve this one for yourself. Now, let us check. Let's identify the given first. We have a sub 1 is negative 3. R is 9 divided by negative 3, that is negative 3. And our a sub n is negative 177,147. The missing term is n. Again, we will use the formula for geometric sequence. A sub n is equal to a sub 1 times r raised to n minus 1. Substitute the given. We will get negative 177,147 is equal to negative 3 times negative 3 raised to n minus 1. First step is divide both sides by the constant negative 3. So we will get 59,049 is equal to negative 3 raised to n minus 1. Now, we need to get the equivalent value of this one. That has a base of negative 3. So, that would be negative 3 raised to 10. So, negative 3 raised to 10 is equal to 59,049. Now, let's equate the exponents. We will get 10 is equal to n minus 1. Transpose negative 1. We will have 10 plus 1 is equal to n. So, our n is 11. Now, we can get the sum by substituting all the given values to the formula. So, we will have S sub 11 is equal to negative 3 times the quantity 1 minus negative 3 raised to 11 over 1 minus negative 3. So, simplifying, we will have S sub 11 is equal to negative 132,861. Did you get it right? Okay. Now, let's have some examples of word problems. Lisa deposited 850 pesos into the bank in July to December. The amount of money she deposited into the bank increased by 25% per month. What's the total amount of money in her account after December? Round your answer to the nearest peso. So, let's identify the given first. We will have first three terms as 850, 1,062.5, 1,328.125, and so on. How did we get that? Our R would be 1.25. Since nag-i-increase siya ng 25% per month, so, kailangan nating i-multiply yung 850 by 1. Saan galing yung 1? Yung for the whole month. Plus 25, that is yung 25%. So, we need to multiply 850 by 1.25 to get 1,602.5. Then, need to multiply by 1.25 again to get the next term. And our A sub 1 is 850. Our N is 6. Bakit 6? July, August, September, October, November, December. So we have 6 months. Now, what formula should we use? We will just use the first formula to get the sum of first 6 terms. So, substitute the given 850 times 1 minus 1.25 raised to 6 over 1 minus 1.25. We will get 9,569.97. Anong sabi sa problem? Round to the nearest peso. So, kailangan whole number lang. So, S sub 6 is approximately 9,570. Therefore, the total amount of money in her account after December is 9,570 pesos. Now, for the next problem, please pause the video and answer this on your own. Then continue watching the video after you have answered. Now, let us check. Let's identify the given first. A large school board established a phone tree to contact all of its employees in case of emergencies or inclement weather. Each of the 3 department heads calls 3 employees, who each in turn calls 3 other employees, and so on. How many rounds of phone calls are needed to notify all 9,840 employees? So, given, our A sub 1 is 3. Bakit 3? Kasi magsisimula siya sa 3 department heads. Then, our R is 3. Bakit 3? Kasi yung 3 department heads, magko-call siya sa 3 employees. Then, yung 3 employees, magko-call din sa other 3 employees. So, para siyang times 3, times 3, times 3. So, our R would be 3. Then, we have a total of 9,840 employees. So, our S sub N is equal to 9,840. Now, we need to find N. Ang hinahanap dito is N. Ilang rounds of phone calls daw yung kailangan. So, we will just substitute to the formula. We will have 9,840 is equal to 3 times 1 minus 3 raised to N over 1 minus 3. So, simplify, we will have 9,840 is equal to 3 times the quantity 1 minus 3 raised to N over negative 2. Let's first multiply by negative 2. So, we will have negative 19,680 is equal to 3 times 1 minus 3 raised to N. Then, divided by 3 on both sides to remove this constant, we will have negative 6,560 is equal to 1 minus 3 raised to N. Then, transpose negative 1, we will have negative 6,561 is equal to negative 3 raised to N. It is just the same as 6,561 is equal to 3 raised to N. Now, we need to find equivalent value of 6,561 to the base 3. That is the same as 3 raised to 8. So, 3 raised to 8 is equal to 3 raised to N. Let's just equate the exponents. Our N is 8. Therefore, 8 rounds of phone calls are needed to notify all of the employees. Did you get it right? Alright, well done. Don't forget to answer your activity sheet and make a short reflection about the topic for this module. Bye everyone!